Good afternoon, everyone. Welcome on in. As y'all are joining, you can put a little note in the chat where you're tuning in from. Today, I'm tuning in from the unceded territories of the Squamish, Tsleil-Waututh, and Musqueam people, also known as Vancouver, BC.
I guess on this end here, well, in the past we've all done this just from BC, but now I'm going to be joining us from Edmonton, which is located on the territory of the Niheya, the Niitsitapi, the Métis, Nakota, Dene, Haudenosaunee, and Anishinaabe lands, and they're part of the Treaty 6, 7, and 8, and the homeland of the Métis. And I'm really happy to be situated right near the lands of the Enoch Cree Nation, where they have a lot of forests. So it's nice to see that.
All right, the chat should be up and working now. Thanks, everyone, for letting me know. Looks like we got a lot of people tuning in from Victoria. Got some people from Quebec. That's awesome. If you're tuning in from a school, feel free to put the school. Maybe I'll try to see. Oh, yeah, we've got some grade 3 students in West Kelowna. Very nice.
Nice.
That's awesome. So cool to see where you're all joining in from.
Sure.
I'm so excited for the Learn to Draw today. We're going to be focusing all on the Western rattlesnake. I'll be monitoring the chat today, and I'll also be monitoring the Q&A. In case anyone has any questions for Julius, I can bring those forward or try to answer them on my own. I'm going to introduce Dr. Julius Chitney now. Julius is a scientific illustrator and natural history fine artist. As always, we're so delighted to have you with us today to help demystify and understand a little bit more about rattlesnakes, specifically the Western rattlesnake. So without further ado, I'll hand it over to him
Okay.
to get us drawn.
Well, thank you so much, Kate. I appreciate that. Thanks to Kate and Aurora, who've been putting so much effort into these as well. And yeah, today we are dealing with rattlesnakes. I'm happy to join everybody here again as well. Thank you, everybody, for joining us I see from all over the world. This is really nice to see that, actually. Definitely from a wide range in North America. I'm seeing everything from BC to Ontario, California, and Florida. This is great to see people from all over. It's very rewarding for me to be able to see how many people and communities we're reaching with these broadcasts. So I was proud to be a part of them. So rattlesnake. So we are just past Halloween here, and so we always kind of select a being with Sierra Club VC to try to select one that is a good one to demystify and also to sort of devilify in the sense that there's a lot of fear associated with many different animals. And some of it is not as warranted as it should be, and a lot of it is propagated by sort of word of mouth or the media and so on. There's a lot of hype sometimes, and whereas it is important for us to respect and provide the respectful distance between us and wild animals, for example. Some of the time, these fears can be a little bit unwarranted, and so we're going to cover some of that and try to untangle some of this today with rattlesnakes, which a lot of people do fear. And there are very many rattlesnakes in North America, but they're a fascinating and beautiful set of beings. And let's learn more about them. So with that, I'm going to start sharing my screen, and then we'll have a preview of the kind of drawing that we're going to end up with today. And so here we go. It should start up. There we go. In a moment, it should show up. And so we are dealing, today we're going to be covering a species of rattlesnake called the western rattlesnake. And it's a close relative of the prairie rattlesnake, which many people will see east of the Rockies. The western rattlesnake more exists in the west of the Rockies. It has several different names, including the North Pacific rattlesnake and a few other ones. So it's actually a close relative of the prairie rattler, and it's sometimes even listed scientifically. Its name is sometimes listed as Crotalus viridis oreganus, which is a subspecies of the prairie rattler, but it's often also recognized as its own species, and that's how I'm going to be dealing with it today, as the western rattlesnake, the Crotalus oreganus. And in fact, the rattlesnakes are a New World group of snakes. They exist only in the Americas, from North America to South America, not just up here. But the pit vipers, I should say, in general, are a North American. Okay, let me disentangle that. Pit vipers occur in several parts of the world, and we'll talk about why pit vipers are important here. Rattlesnakes are a subset of pit vipers. Pit vipers do exist in the Americas, and rattlesnakes are exclusively America's related group of pit vipers. So a bit of complex sort of nesting of taxonomy there. They exist in much of North America, but they do also reach up into Canada in a couple of places. And so we have on the West Coast, we have the western rattlesnake. In Alberta and Saskatchewan, we see prairie rattlesnakes. And then in Ontario, we have something called a Mississauga, which is a rattlesnake that is a little less closely related to some of the others. It's in a different genus, Cistruris, not Crotalus. So kind of neat that one. Very beautifully colored, by the way. If you're in Ontario and you happen to see those, nice. But one of the things I love about snakes in general, and rattlesnakes especially, is also their beautiful color patterns. And pit vipers, as a group, of which rattlesnakes are a member, have some absolutely extraordinary colors. And they exist in a wide range of areas, from desert to rainforests and all sorts of things. Even some of them are semi-aquatic, really neat animals. And some of them are arboreal. They live in trees. Some of them, like rattlesnakes, are ground dwelling, but so many beautiful colors. And we're going to cover a little bit of that as well, actually. So this sketch here is what we're going to be looking at for what we're aiming to do today. Now we're drawing a relatively simpler animal as its shape goes. It doesn't have any legs on the outside, no visible legs. So it's head, body, and tail, and then various parts there. But there's a lot of interesting features within this rattlesnake, and so we'll have a lot to talk about. Plus, it might seem really easy and at first glance to draw a snake, basically a rope, effectively, right, with a head, and in this case a rattle. But it's a lot more complicated than that, and there's a few kind of fun little bits that I like to and throw in there, and techniques that involve sorry, what I'm looking for here is, I'm a little bit tired. I think bear with me. I've not gotten the best sleep in the last few days, so I'm still catching up. So foreshortening and perspective are going to be interesting components of what techniques that we're going to be using in drawing this snake. And I love drawing animals that have this sinuous kind of a shape. Snakes are one, eels are another, many kinds of other fish and so on, that have a lot of bends in their body, because it's a challenge to be able to draw those bends properly. You don't want to draw it so that it's bending too sharply, for example. Sometimes some animals can only bend just so much, and snakes are wonderfully bendy as they go. And there's certain ways that it's fun to depict bends. I mean, octopus limbs are another one that fall into this category of really bendy and they make tangle and so on. I love these kinds of animals. Anyway, so let's start on this. So what I've done, I've selected a kind of an 8.5 by 11-inch page. You know what I'm going to do here? I'm going to actually enlarge this a little bit on our page. This is not something I usually do, but because we're dealing with a pretty compact animal here. I'm just going to make this a little bit bigger. So it's going to be easier for us to fit it on the page and easier to see. Okay. It's just a little bit larger than I had originally set it up, but this works just as well. Okay, so there we go. So that's, again, now this snake, how big does it grow, right? I mean, just to get an idea of what we're dealing with here. Normally, Western rattlesnakes, they are sort of an in-between sized rattlesnake. They're not the giants like the diamondback rattlesnakes or really, really tiny ones. The Mississauga is actually a very small rattlesnake in Ontario. These ones can grow up to about roughly close to a meter in size. So, it's like kind of like that. So they're not huge. And the cross section is also going to be very small when you think about how when you stretch it out, that's the full length of it, not like this clump of a snake that we have on this drawing here, right? That's like going to be what, maybe a foot in size or less in that clump. They're very compact. And so they're easy to kind of, they find places to hide under bushes and so on. So it's easy to miss them. Also because their color patterns are beautifully camouflaged. So we'll talk about that as well. But we're going to start drawing this snake. And as we go, I'll talk about the various parts of its life history and the things that we can do to help it or to, enhance our interaction with it, to make it less dangerous seeming, less unnecessary fear, more respect is what we want to develop. Okay, so I'm going to first shut down the sketch part. And then now we're going to start in stages as usual. So I've got it set up so that I'm doing it digitally. You can do it, of course, either digitally on a tablet or on a regular sheet of paper. Again, I've kind of set it up so that the size of the paper is, or the size of my workspace is the same as it would be for an 8.5 by 11-inch letter-sized page. And then there's two things going to happen here. One, I'm going to sometimes use a sort of a lighter strokes with the pen. In those situations, I'm going to coat that with a red color here. You can use your pencil or pen, but just when you see me drawing in red, keep in mind that I want you to make those very, very light strokes. So those can be either erased out or be less visible in the end. The black marks that I make are going to be the more permanent ones. So that's something to keep in mind. So that's important to say because we're going to start with some of these very light lines to kind of set up the overall shape of the snake on the page, okay? And there's going to be certain loops in its body, right? So we want to make sure that we get those set up and we have the right proportions. Because as artists, we struggle a lot with making sure that the subjects we're drawing have the right proportions of the various body parts. So here we go. We're going to start here. I will start, as I mentioned, with red. So the very first thing we're going to do is we're going to draw basically a big egg. Okay, this is going to be a large part of the snake. Not the whole snake, but a large part of it where its body resides. So I'm going to just draw this egg shape, pretty close to the center of the page, ever so slightly below the center of the page, but pretty close. And again, this should be a very, very faint line. You don't want this line to be highly visible afterward. It'll help to guide us in drawing parts of the snake. Doesn't matter if it's not perfect. You can see I kind of, didn't make a perfectly smooth egg that way. Incidentally, these snakes do not lay eggs. Pit vipers and rattlesnakes don't lay eggs. Snakes are neat. They have 3 different kinds of ways of reproducing. Some are called oviparous. Oviparous animals lay eggs, like birds, and like some other snakes, like many lizards and so on. Rattlesnakes are not. There's another group of animals that have, and another group of snakes, in fact, that have a mode of reproduction called viviparous, which means that they give birth to live young, and their young develop sort of in a similar way that mammalian young have with not quite a placenta, but a way of integrating them into the snake's uterus. Rattlesnakes are different that way. In general, most undergo what's called ovoviparous, or they're ovoviparous. A complex sort of word, but what it means is that they effectively have eggs inside that hatch inside their bodies. So they don't lay eggs, but they have these baby snakes that are born after effectively hatching from eggs within the mother's body. So interesting combination of the two. So yes, egg-shaped start to the snake, but these snakes don't lay eggs. They give birth to live young, little tiny things. They must be absolutely adorable when they're born. Okay, so that's the first egg shape. The second, we're going to continue with this again, these light lines. It's another sort of egg shape. This one is just going to help us define some of the loops in the snake's body. And this egg is sort of like crossing the line at the top of the first egg in this sort of a way. So slightly slanted, it's smaller, overlaps that one. It's a little below halfway that it kind of goes in. It's kind of like an egg balanced on the top of another egg when looking at it slightly from the side. Kind of weird way to think of it. These will all help us determine where the body of the snake goes. And in the end, remember, if it's not perfect, it's okay, because these snakes are bendy. They can arrange their body in a whole lot of different ways. It doesn't have to be perfect like this, right? So don't worry about it if it's not perfect. One more egg here. This will be, again, intersecting these two, and it'll be tangential to, or sort of exactly lining up on the edge of the biggest one, like this. It starts out here and basically is like a little subset of that top one, and it kind of intersects the little one as well, like that. Okay. In total, we're going to have 4 eggs to start us. This is 3 of them. The last one actually will correspond to the snake's head. And that one, we're going to put basically touching that second and the second smallest egg, or the smallest one currently, and it'll look like this. Oops. That actually, yeah, and I'm kind of off with that. Again, these don't have to be perfect in shape. They're kind of helping us to establish where the parts of the body are. If you can get the shape to be close, that's great, but doesn't have to be perfect. Okay. So there, that doesn't look like a snake yet, but you can start to see where some of those loops in the body are residing. Okay. Now we get into the meat of it. Now we're going to switch to heavier lines. I'm going to switch to a black color to make it obvious that's what we're doing here, and I'm actually putting on another layer so we don't mix the two up. I'm going to start with the snake's head. There's not a lot of parts to the snake, right? We have a head, we have kind of the body and the tail, and the body and the neck, the body and the tail kind of look like they merge, right? And you can't really easily tell them apart when you don't have legs to set them off, basically. But snakes do actually have a tail and a neck. The tail of snakes, incidentally, is very short. It seems kind of almost counterintuitive, but they have a very short tail, and at the very end, it's kind of stubby looking. It's just a very long body. So it's kind of interesting that way. And we know this because if you look at the evolution of snakes, they evolved from animals that had legs. They evolved from a group of animals related to lizards. And in fact, the Komodo dragon is a member of the group of lizards called varanids that are actually closely related to the ancestors of snakes. And so when you see a Komodo dragon or a monitor lizard, look at them and you can sort of see some of the similarities in shape to snake bodies or snake heads or the forked tongue of Komodo dragons that flicks in and out. Kind of neat that way, but they're actually closely related. And the ancient giant mosasaurs, or some giant mosasaurs from the Cretaceous period, from when dinosaurs were around, those water-dwelling, flippered giant animals, reptiles that swam in the oceans, were closely related to varanid lizards like Komodo dragons, and therefore also sort of closely related to snakes that way. So it's kind of a neat bit of family tree stuff happening there, where snakes are placed kind of thing. And yes, so they evolved from land-dwelling, legged animals, and the earliest snakes had legs, tiny legs. And in fact, today you see a lot of really neat stuff happening among lizards. Some lizards have legs, most lizards have legs, some don't have legs. Some have teeny tiny legs, some only have 2 legs, either in the front or in the back set. So there's interesting things sort of experiments happening with evolution even today in terms of lizards sort of transitioning to legless conditions. Snakes are one example of a group of reptiles that have succeeded fully in this, although some snakes still have claws where their legs would have been. So neat kind of a thing there. But weird, neat animals. Now I'm going to put the head of the snake in. We're going to start with the head. And I'm actually going to zoom into this part so that we can see this in more detail. There, that last loop that we made, we're going to put the head here. Now, the shape is pretty close to what we want, but there are slight differences. So, bear with me as we do this. The snout of the snake is at the front end. It's holding its head sort of upward, and that kind of comes off a little. Whoops, hang on, sorry, hit the wrong spot. That's okay. Move it this way. The snout is right here, and it kind of comes off a little bit from that egg shape. It's not a hooked snout, but it's kind of it's not totally rounded either. It's a little bit kind of flat on the front. So that's kind of what we're seeing here. I'm also drawing this head not right from the side, but a little bit at an angle. It's more interesting, I find, to draw things slightly at a different angle than right from the side or right from the front. As an artist, that's something that I enjoy. So we're going to see it slightly from the side and slightly from above, just so you know what's happening here. The underside of the head is here, and it quite closely follows the line we made. And then the back comes up here like that. Now, the eyes of the snake are located near the very top of its head on either side. And in fact, there's a bit of a bulge on the top of the head where the eyes are. So the eye on our side, the snake's left eye, is below the level of the edge of its head. But the right eye, we can see the bulge. So that's what we're going to put in here. And so just behind that snout, there's this bit of a bulge where the eye sits under it on the other side of the snake's head. Okay. And then the top of the snake's head kind of comes off. And just bear in mind that it kind of comes off and ends a little bit like that. It doesn't fully follow that egg shape we made. The egg shape was a general idea of where its head is and which way it's pointed, but the line kind of comes off a little bit like that. So that's the shape of the snake's head. If you looked at it from above, you don't have to draw this, but I'm kind of drawing this. If you look at it from above, the snake's head looks a little bit like this. Here's the eye and the snout. It's a little bit triangular. Now, and there's the other eye here. Okay. There's the little bit of the mouth, and there's the tongue comes out here. Okay, and then its neck comes out the back. There's a little bit of a bulge, a slight bulge, not that much maybe, a slight bulge of the way that the head comes off the neck. And the shape of the head is kind of helpful to identify them as well. A little bit triangular shaped. And then there's like muscles for jaws and so on as well, because they have to move their jaws really quickly when they snap at prey, for example. Okay, and then they've got these eyes with sort of cat-like pupils. Really cool. Anyway, you don't have to draw that, but that's kind of the overall shape of the snake's head. And then you've got there's a center line of scales and so on, a bunch of scales. We'll deal with that later. But so that's kind of what we're seeing. We're seeing this project a little bit sideways. And we're going to put the left eye in place. You can't see the right eye of this snake that's in our drawing, but we can see the left eye. And rattlesnakes are kind of cool. And I think this is one of the reasons people fear them. Rattlesnakes have it's like this resting angry face with their eyes. It's like if you look at their eyes, they always look like they're angry or pissed off, or they just kind of look like they look mean. And I think this is unfortunate in a sense for how we read it, because the way like our eyebrows go when we're angry makes our eyes kind of do a similar thing to the natural shape of rattlesnake eyes. It doesn't mean they're mean or angry. They're not. It's just that's the shape of the eye. They can't move their eyes. They don't have eyelids. Snakes don't have eyelids. This is how they differ from lizards and many other animals. They don't have eyelids at all. They can't blink. So they're always having this resting angry face. They're staring at you with these poor things are looking at you like, I'm not angry, but I know I might look angry, but try not to read it that way. but they've got this kind of the way that the top of the eye goes, it looks a little bit like a frown. Just remember, that's not what it means. They're not angry, they're not mean, they're not looking to hurt. It's just their face. And then they've got this really neat pupil, the vertical pupil, like a cat. So it closes that way to reduce the amount of light. Now, rattlesnakes are largely nocturnal, or what we call crepuscular, which means that they are active. Nocturnal means they're active at night to hunt and mostly active. And crepuscular means that they are active at dusk and dawn. I mean, that's both is often true for them. Rattlesnakes do actually hunt from dusk to dawn. So they're more accurately described as nocturnal in that sense, but they will start becoming active at a time when other animals that are crepuscular, that are only dawn and dusk, when the sun has gone down, but there's still enough light to see more than at nighttime. So they have these pupils that can narrow a lot during the daytime, although they're also sometimes active during the day, more than some other snakes. But when they are at night, that pupil opens up and their pupils become a lot larger. So they have a huge range in how much light they can let into their eyes. The pupils are protective in the daytime, but at night they open up and then they can see much better. Interestingly, rattlesnakes they have a lot of what are called rods. These are sensors in the back of their eye on the retina that take in light and that allow that light to be registered by the nerves. They have a lot of the ones that are adapted for night vision. Okay? So they have pretty good night vision. They also have what are called cones. These are special receptors in the same part of the eye that we use for color vision. So they may have limited color vision as well. So they're not fully nocturnal. They're also active during the day. Color vision is useless at night, really. But mostly they're not nighttime active animals. Okay, so that's the eye. We're going to give it a mouth now. It's a very long mouth. Rattlesnakes have these long mouths, but they can open it up really wide and strike far so that they can inject venom into whatever prey they're eating. And they need to be able to have a wide mouth because they don't chew their food. They have to swallow it whole. So after they've dispatched their prey, which is usually small mammals like shrews and voles and squirrels and chipmunks and whatever else they encounter that might be active at night, they can't chew them after they've finished them off. They have to swallow them whole, usually head first. So the mouth has to be wide enough to be able to accommodate this. But it's also limiting what kinds of foods they eat. So they're not going to be after us. There's no way they could do anything with us. We are definitely not their prey. There's no way they're hunting us because we're way too big. There's no way any rattlesnake would be able to swallow even, a part of us. So they're actively looking to avoid us, actually. That's an important thing to remember. So anyway, the mouth.
To remember, Julius. We've got a question in the chat here I wanted to bring to you. The person's asking, are the pits on the muzzles eye spots?
Ooh, this is a very interesting question. And if we can hold off for a second, I'm going to finish the mouth. That's one of the next things we're going to deal with. And that is so cool. So very, very cool. Thank you for that question. The pits, and this is where the term pit viper comes from, the group of snakes to which rattlesnakes belong. Really interesting, and we'll get to that in 1 second. So yes, I will answer that. Okay. So here we go. The mouth, just so that we give it a little bit of a character here to start with the mouth, it goes way back here. Yeah, so wide open mouth, right? They can. And there's a little bit of at the top, at the front, it kind of goes up a little bit. And that's where we're going to put the tongue. We're going to have the tongue flicking out. So actually, I'm going to move that separate head drawing oops, I'm not sure why it's not looking. I'm going to move that separate head drawing actually for now because it's going to be in the way. I'm going to get out of the way there. I'm going to put the tongue in place here. So we're going to talk about senses, 2 kinds of senses here in rapid succession, okay? Well, 3 or 4 actually. Superpowers. Rattlesnakes have superpowers. This is important to remember, okay? So the tongue is the next part. So we have the eye in place, the little permanent frown. Really adorable in my opinion, but anyway. The tongue comes out of the mouth. Whoops, I can move it here. Okay. The tongue comes out of the mouth like this. I am drawing it fully extended. Interestingly, as many of you will probably know, rattlesnakes and snakes in general, and several types of lizards, including their relatively close relatives, the varanids, like the Komodo dragon, have these long forked tongues that they can flick out of their mouth, extend very rapidly in multiple times. Why on earth would an animal do this? Why would it evolve such a thing? Well, it's really cool. Rattlesnakes, I'm going to put their nostrils in, okay? They have nostrils like many other animals, right? Okay. But the nostrils are used for smelling, and rattlesnakes incidentally have a really good sense of smell, right? They're sit and wait predators. They wait for their prey to walk by, they're waiting, and then when they're near enough, they snatch at them, okay? So their sense of smell is important. But they have another superpower. They're able to sense airborne chemicals in a different way as well as just with their nostrils. They can use their tongue to pick up little tiny droplets of water in the air, within which other chemicals may be dissolved. So these chemicals might not be as volatile, not as easy to vaporize into the atmosphere that you could just smell it. But they might be dissolved in tiny water particles in the air. But this tongue, they flicks out, and those particles stick to it. They pull the tongue back in, and then on the top of their mouth, they've got this special organ, these two little slots into which then they stick the two forks of the tongue. This is called the Jacobson's organ or the vomeronasal organ, and it is highly, highly sensitive to chemicals, just like a sense of smell, but it's an auxiliary sense of smell. It picks up chemicals that the nose might not. And so this is one of their superpowers. The snakes, when they're flicking their tongue out, are tasting the air. They're sort of smelling it, but it's more like tasting it because they're using their tongue. But they don't have the taste buds on their tongue. They have the sensors inside on the top of their mouth, on the roof of the mouth, in the Jacobson's organ. So that's why they flick out their tongue. And in fact, some have suggested that the two forks might give them a little bit of a directional sense of smell or sort of taste smell. I'm not sure how well that's supported, but it also increases the surface area on which these chemicals can stick, and that then is able to sense them in the Jacobson's organ in the head. Really cool superpower. So that's some of it. Snakes can't hear very well, but they can feel vibrations in the ground through their body. So that's kind of how they pick up that. And now we get to the other superpower that you asked about, pits. The pits are a special organ that is found only in this group of snakes. Now, there's another group of snakes, the boas and pythons, have also some special pits along their sort of the lips effectively that are sort of similar, but they evolve differently. Pit vipers, including rattlesnakes, have these, and I'm going to put one here. There's two of them, one on each side of the head. It looks like a nostril. It looks like a second nostril between the nostril and the eye. And there's one on each side of the head. As the name describes, it's a pit. It's kind of a gap, a hole, and it's facing forward. There's a membrane, kind of like an eardrum in it. And there is a special set of very, very sensitive cells in the back. What this pit does is it senses heat. And so it actually isn't just a spot of color, it's actually a depression in the surface of the face. If you look at rattlesnakes, you'll see this, and it looks like they have two sets of nostrils. It's the one that's further back, that's the pits. The really cool thing about this is that it truly is kind of a superpower, because the snake can sense heat directly, infrared radiation, using these pits, but it overlays this information on the visual field. So it's effectively also seeing the heat distributed over what it's seeing. Now, it's not very detailed. It's not like it doesn't have a lens. It doesn't have like that kind of image forming capability, but it can effectively map on its visual field where the heat signature is. So if it sees something moving, it can tell if that's what's glowing. Why does it matter if it glows in heat, in infrared? Why does it matter if it's warm? Well, because these snakes hunt warm-blooded mammals. And so their prey is what's glowing in infrared heat or in infrared radiation, which is heat. And so they can actually locate where it is because they have two pits, and it gives them this sort of binocular heat vision. It allows them to not just gauge where it is, but how far away, in the same way that our two eyes give us depth perception. So the snake overlays all of this information on its visual field, and it can tell where the heat source is. And they can tell the difference between about 0.003 degrees of a Celsius difference using these pit organs. And in fact, they found that snakes that are blind, that don't have an ability to see, are still able to accurately snap at prey using just the pit organs. And to do this, I think it was accurate to within about 0.2 degrees Celsius difference. It's like a really, really small, like a fifth of a degree is all it had to be for them to be able to do this effectively. So even a blind rattlesnake can still make a living catching food at night. And again, it's also important that it be at night, right? Because then you don't have to worry about the heat generated by the sun, say, overwhelming the heat generated by animals from their warm-blooded metabolism. And so at night, they stand out more as heat sources. So really need superpowers. So
Awesome, Julius. I've got a backlog of questions all about snakes' heads. So number one is how is it possible that their mouth can detach? And then a little bit on that, what are their fangs made of, and how far could they extend their jaw?
Interesting. Oh, very interesting question. Okay, the dislocation of the jaw is an interesting one. I'm not sure how much rattlesnakes do this. Now, in some snakes, like constrictor snakes, the boas and pythons, they actually have to swallow enormous prey. And what they can do is their jaws can effectively detach from the upper part of the skull. And when you look at a snake that is swallowing a very large meal, it looks ridiculous because you have the upper part of the skull here and the lower jaw is down here, and the rest of the animals here, and there's no way they can connect. They're not connected. They can dislocate, so they can widen their mouth even more so they can swallow. And of course, their skin and everything is really stretchy, so they can actually stretch out a lot to swallow these big meals. Now, rattlesnakes don't generally have to swallow that big meals. They're not constrictors. They don't have these giant meals, but they have very flexible jaws anyway. And interestingly enough, some of snakes, like the constrictors I mentioned, that have to swallow these giant meals, well, how would they do that? So they have this funky way where the two sides of their mouth, they can use muscles to effectively walk the teeth along the prey separately. And so you can see their head kind of going back and forth like this as they basically walk their mouth over the prey and swallow it that way. Really neat kind of other superpowers of dislocation as well. Most of us aren't capable of anything near that. And if we are, it's usually a medical condition. But snakes have superpowers like this. So that's one thing. What their teeth are made of, I believe it's just bone like the rest of their skeleton. They're not cartilaginous like sharks. Sorry, the teeth of sharks are bone, but their bones of snakes are not cartilaginous, just, they're regular bone as well. They would have some enamel on them, I believe, although I'd have to check on that. They're very, very narrow, so they're kind of fragile, so they have to keep them retracted in the mouth until they're needed. And when they are needed, they can extend them, and their mouth opens up really wide. And in fact, rattlesnakes, to answer the last question, rattlesnakes can open their mouth to almost like 180 degrees, like ridiculously wide mouth, which is important because then their teeth are painting effectively forward to grab the animal they're after. It's a much better chance of grabbing it. Probably a smaller chance of it breaking as well by hitting it sideways. And in fact, the typical distance that they strike is about half of their body length. Okay? So that they can actually reach quite a ways out to reach prey, which is important for an ambush predator that basically sits and waits for animals to walk by. If you can reach farther, you can reach more of the prey, more chances to get a meal, basically. Okay, so that's kind of a little bit more about how they feed and their weird mouth anatomy and such. It's neat stuff. Okay, so we're gonna move back along the snake now, to the other parts, because there's other parts of the snake too than just the head that is also interesting, right? The head is a really fascinating part, it's true, but the rest is kind of neat too. So now we're going to start with, we made all of these loops and so on, right? And this is why. The first bit is a bend in the body that's sort of just behind the neck. And so I'm going to start here at the base. I'm going to point to it with the arrow. You don't have to do this, but it's going to start around here. And I'm going to draw a line that follows this egg shape we did up to about here and then kind of comes off a little bit like that. That's a part of the body just behind the neck. And then the top part of that body, I'm going to put just a short arc here for now for a reason, like that. It's kind of like a tire tube, I guess. And then now we're going to add the actual neck of the snake to connect this part. And you'll see why I made these lines the way that I did. And so now going back from the back of the head, we're going to continue that line. And that comes down and meets this other short line we just did, like that. In fact, we can actually extend that other line a little bit further up to here. And so we're seeing a very, very bendy neck on this snake. These snakes have many, many vertebrae, many more than we have. And if I were to actually even reduce, if I were to show it without those red lines that I just did, that's kind of what we just did there. I'm going to put the red lines back, but a little bit lower opacity so that it doesn't get in the way too much, but it's still visible. Okay, because technically it should actually be light lines. Okay, so there we go. One more thing I'm going to add here is a little bit of a very short line that comes over here. And there's a reason I'm leaving a gap here. That gap right there, that we want to leave open for now because that's where the tail is going to come through. Actually, technically, I should have left a gap down here as well. Okay, sorry. So there's two gaps. We can always like erase out a little bit as well as the tail comes in if necessary. But those are the two gaps we're looking at leaving if we want to from the beginning. That's where the tail's going to come. Also, because, you know, I kind of like to make an image a little bit more interesting. Certain parts are in front of other parts. This is important to learn as an artist of how to do this. And so this is why I kind of deliberately set up these complicated ways for the parts of the body to arrange themselves, okay? So now we're going to work on the snake's midsection. This is all really easy parts because there's no legs, no fingers or toes to worry about. So snakes are easy on artists that way. Okay? This next part here, we're going to start from under the jaw of the snake and continue a line. Whoops, that's not the one I want, this one. Following one of those sort of egg shapes we did initially. And I'm leaving gaps here, a couple of gaps. Okay, like that. And then the top of that body section, this is sort of like the thorax of the snake. And then the bottom half of that. So you're starting to see other loops. Again, more like tire tubes. It's like a series of tire tubes that are linked together. Very interesting sort of an animal in that shape. In fact, you can also add a very light line or a dotted line to the midline of the snake's body like that. You can actually, we're seeing it a little bit from above, right? And so we can actually see the midline of the back of the snake. You can sort of do that here too, near the neck, dotted line, like that. Okay, I'm gonna move this over a bit so we see the whole snake. Then there is another large part of the body here. This is that sort of the back end. Not quite the tail yet, but it is sort of the back end of the abdomen. So the snake's digestive system will go all through this part here, right from the mouth, right through to the base of the tail. So there's a lot of intestine and stomach and so on in there. There's a lot of space. And the lungs are actually very long and narrow as well, interestingly enough. So here's the rest of the body of the snake. And if you're kind of following along, you can sort of see where these various tire tubes connect with each other, right? It's not like they're separate tire tubes. They actually do connect into one single tube. But as we've been drawing it, a little bit more complex shape, it's not as obvious, maybe. Okay. And again, I'm leaving some gaps here. for that tail. Whoops, and I kind of didn't leave a, no, I did leave a gap here. Let me just recheck on a sketch thing here. Yes, okay, I know why I did that now. Ha ha. Sometimes I have to make notes for myself. Just planning ahead. Okay, again, a little dotted line that kind of shows the snake's, the midpoint of its back. I do this because the cross section of a snake, the shape of its body, isn't exactly circular, right? Different snakes have different cross-sectional shapes. So for example, boa constrictors have, if you looked at it in cross-section, the shape of the body would actually be in some places almost square. Other snakes have a lot more circular body, and rattlesnakes have a body that's shaped a bit like this. It's kind of like a rounded triangle almost. More rounded in the bottom, but the back comes to a little bit more of a point. Not quite, it's still rounded, but a little bit more. And also different parts of the body have different cross sections. So very near the back of the head at the neck, it's a little bit more square, but the further back you go, it's a little bit more rounded with this little bit of a crest on top. Not crest, but a little bit more pointed on top. So snakes are a lot more complex in shape than maybe at first glance it would indicate. So that's why I'm adding this little bit of a dotted line along the back. Now for the tail, okay? The tail of the snake, or, well, the back end of the body and the tail. The tail is actually very short, and it's really hard to see exactly where it comes out, or where it starts out. But here's what we're going to do. We're going to continue from the back end of the body, and here's why I left these gaps here. This tail comes up here, ends over there on the bottom side of it, and then the other side starts up here, and is bent and is pointing upward. There's a reason why it's pointed upward, because this snake is coiled up in a defensive posture, and it's rattling its rattle. This is important because this is one of the cool effects, or the cool features of a rattlesnake, is that they have this special feature that no other snakes do, and I will put that in now, the rattle. The end of the tail has this neat, really, really neat feature, and it's, what would you even call it looking like? I mean, it's not exactly, it's like almost like a cob of corn. You think about it, it's sort of complex in the same way. It's got these components that look almost like corn kernels. So if you thought of anything that looks sort of similar, it's a little bit like a cob of corn, but a very simple cob of corn. But all of these little segments are hollow, and they have, I think, bits of keratin in them that when they shake, they make a sound, a buzzing sound. And the snakes, rattlesnakes have special muscles in the base of their tail that can rattle and shake their tail, but super fast. They're one of the fastest known muscles. They can vibrate at about 50 times per second, right? And they can keep that up for a while. And so some rattlesnakes create more of a buzz sound as a result. And this rattle is a superpower that makes them friendly to us. Okay, why do I say that? Because a rattlesnake doesn't want to bite you. It really doesn't. And it's not that it's being nice. It's actually for its own good. Any time that the rattlesnake bites something, it risks breaking its teeth. It risks getting injured by whatever it's biting. It could endanger its life. A lot of things that it could bite might be a lot larger, could squash it. We could, right? And so it really doesn't want to bite anything but what it knows to be its prey. And those pits can tell it also how big an animal is, right? And so it can tell, oh, that's a really big, like, walking thing in front of me, like a person. I don't want that. I know I'm going to avoid that. So what a rattlesnake does is it hides away from where we might step on it. Sometimes we accidentally might step too close, in which case the snake is like, okay, I don't want to bite you, so I'm going to make a lot of noise to let you know that I'm here. Don't step on me. Remember this noise. If I bite, it hurts. Therefore, try to avoid it. I don't want to bite. And in fact, rattlesnakes don't generally bite. They only bite when they're harassed. They generally are, and I've seen videos of people pushing, like with a stick, pushing snakes off a road to avoid getting run over. And that snake is not trying to bite the stick, it's just trying to get away. So even in those situations, so we don't try to handle them ever. We want to respect them, but they're not going to try to bite us. They only do that as a last resort. And even in bites, it's something like out of, I remember a statistic of something like out of 7,000 or 8,000 bites that were recorded, there were only about 5 that resulted in death. So like a really, really tiny proportion. You're highly unlikely to get to die from a rattlesnake, even if you're bitten. And even then, about 1/5 of the time, they don't even inject venom. Right? They can choose to or not to because they got special muscles that contract to inject venom on choice, basically. So they don't always even inject venom. Anyway, so there we go. So that's the shape of the rattlesnake. They also kind of are cool in that they have a series of scales on their belly that look very different. I'm going to put some of the scales in place here. So on their head, they've got some larger scales. Here and there. And then they got a row of them along the lips that are a little bit larger, top and bottom. And then they have different shaped and special shaped scales in different parts of their body. So I'm not going to put them all in because that's going to take a whole lot of work. And they got tinier scales on the top of their head. That's just some examples of some of their scales. And then along their body, they have, and there's this big scale sort of above the eye. On their body, they got these long, neat, sort of keeled scales, which means that they have like a ridge along them. They're long like this. Now, if you want to, you can add the scales to your rattlesnake all over its body, and they're pretty similar. In some places, they're a little bit shorter, sometimes longer, but it's pretty much like that, continued over the whole body. One thing to note is that when you're drawing scales, try to keep in mind perspective and foreshortening. When you're going around the edge of the snake, those same scales will look like they're compressed because they're sort of pointed a little bit away from us, right? And then the closer you get to the edge, the more compressed they look until at the very edge, they almost vanish. Okay? The longest, sorry, I put them in the wrong direction there. This is good to keep in mind. This is another lesson. The scales are pointed backward. This also helps them to move so that the scales effectively give them a little bit of traction against objects to push off. Okay? So they're pointed backward. So technically, I should have drawn those scales at the edge facing the other way. So they're pointed this way. But again, they will get more and more compressed looking toward the edge of the snake there. And in the middle here, because here the snakes, they're always pointed toward the snake's tail. Okay, these scales like that. So you can continue this if you want, but keep in mind that in different parts of the snake, you try to follow the contours of the body in how you draw those scales. And near edges, those scales will look more compressed or contracted. I love doing that part for artwork to show these perspective effects, but they do make things a little more complicated, but this is valuable things to learn as an artist. Now, the last thing that I'm going to show on these snakes, on this particular snake, is a bit of the color pattern. Something to keep in mind, though, as we're doing this is to keep in mind that these snakes have these beautiful camouflage color patterns. They hide very well, so we have to be careful to avoid stepping on them, right? But listen for the rattle. They don't want to bite you. Unfortunately, a lot of people have a lot of unwarranted fear for them. There's a lot of hatred towards snakes, and in some places, they actively actually hunt snakes. They have these campaigns to gather up and kill rattlesnakes, which I think makes me very, very sad. There's no good reason to do that. In fact, rattlesnakes are very helpful for us because they eat mice and rats and so on that often are a problem to us by eating our food or spreading disease and so on. Not all of them do, again, but some rodents can, and some rodents are more of an interference for us than other animals. Rattlesnakes actually eat them. So instead of having cats, loose to hunt, rats and mice, it's good to be in an area with rattlesnakes because they do the job for us and they should be there. They're also important food sources for other animals, such as hawks and other predators that actually feed on rattlesnakes. So they're important in that sense in an ecosystem too, to keep an ecosystem complex. The more complex an ecosystem, the healthier it is, the more stable it is. The more animal species that are present in it, the plant species, the more stable it tends to be. And so rattlesnakes are a very important component of ecosystems, and we want to preserve them and protect them. In Canada, rattlesnakes are, Western rattlesnakes in this case especially, are recognized as threatened. They're listed in the Species at Risk Act, and they are monitored for their numbers. It is illegal to hunt them or kill them or to capture them. And so we actually have laws to help protect them from us. And at the moment, I'm also going to change my brush as we do this, because I'm going to show you, as we kind of finish up here, the overall color patterns of the snake, which I love drawing snakes because of the spectacular color patterns that they have. And these snakes have a sort of a base color that can vary a lot, but sort of a beigey brown often. And so I've just changed my painting tool to a big wide brush so that I can cover this area. And I'm not very good at staying within the lines here, but you can actually do this. I'm going to add some parts here that, whoops, underneath that. I'm going to do it like this so that I can see it. That's sort of the base color. And then they have these beautiful saddles of color that is of a darker brown. Kind of like that. Now, oops, I'm going to change this too. The size of the saddle and the shape of the saddle, whoops, that's not what I wanted to do. There. The size and shape of these saddles of color vary along the snake's body. They start out near the neck as kind of smaller splotches on the back, as well as some splotches on their side, these darker bits. And then as you go further back, these get bigger, and there's not very much space between the dark splotches. And then as you hit near the tail, they get even closer together and they become longer, and eventually merge with those splotches on the sides to form these stripes. And at the tail of the snake is actually striped effectively. This is also kind of cool. There's a good reason why animals often have stripes. Stripes can be either for camouflage. In places like tigers, you see are striped, and they live in areas with tall grasses, and that kind of helps to hide them. But in many animals, stripes are a warning pattern. And so the snake wants you to know that it's rattling, right? It wants you to know it's there. So it can do two things. It can make a lot of sound with the rattle, but it can also help you to see it moving by these stripes, these dark and light stripes alternating, make it more visible, especially the part of it that it wants you to see is making a lot of sort of action in terms of sound there as well. So it's well evolved to try to warn us away because it doesn't want to bite us. And it just wants to, carry on doing its own thing. So rattlesnakes, we can do various things to protect them. We want to avoid damaging the lands on which they reside. One of the things they do is, because we're in Canada, it gets cold here, even in the center of BC. It's too cold for them to survive actively in the winter. So they actually go into these dens in the winter, and they undergo what's called brumation, this kind of a hibernation kind of a state. And then in the spring, they come out again. But they only travel 1 to 3 kilometers away from those dens. That's their home range. And so we want to protect the dens so that they have a place to go in winter, as well as the area around them so that we don't interfere with their migration to places where they can go and hunt. Very important for us to be able to protect their habitat. As I've always said, it's important for us to not just focus on an individual species to protect, but its entire environment, because that protects everything they rely on, and the complexity of the ecosystem that is very important for their survival. So everything we can do to encourage people to, let's say, lawmakers to make laws that help protect these habitats are going to help rattlesnakes as well. So again, with the color patterns here, I'm putting a bit of light color underneath the saddles here at the edge, because one other thing that happens is that there's a bit of a light edge to those saddles. You can find lots of really great photos of these rattlesnakes, and they're really beautifully patterned. Some of them are very stark in color, some of them are a little bit more subdued, and it really depends on where they're living a lot of the time, what they blend in best with, which environment. But in general, it's a pretty dry environment in the south central BC area. And if you're lucky enough to see them, celebrate that, because they do hide quite well. I've seen rattlesnakes in the wild, and it is an extraordinarily magical experience to see one up close. And they're so docile. They just want to be left alone. They're not active. They just sit there. They're beautiful. And watch out on roads, especially in times when like morning, because snakes are cold-blooded, they want to warm up. So pavement is warm relatively compared to much ground. So all the time they hang out on the pavement, which means that they're in danger of being run over. So if you're driving in an area where there are rattlesnakes, just keep an eye on the road. It might not be a stick that's on the road. And if you can try to slow down and avoid it, it's best not to try to push it off the road. But if you have a stick, a long stick, access to it, and you can kind of push it along, that might save its life, and they're not out to hurt anybody, but they can be hurt so easily. So I think with that.
Yeah, and that's such an important thing to end on. I know we're running to the end of our time here. I wanted to throw in the last few questions from the chat. The first one is, what color are their eyes?
Interesting, yes. Their eyes are often reflect sort of their base color. So it's sometimes sort of like a golden or a brownish color kind of thing. Really nice eyes in that sense. So I guess we could call it something golden brownish kind of thing.
Yeah. And then another class was asking, how long have you been learning about snakes? And are there any other animals that you are an expert in?
Oh, well, I'm no expert in snakes, so I have to say that. I am an enthusiast, and as a biologist, I have had the opportunity to look at them in certain ways. I've not actively studied them in a research sense. I've looked at other animals that way, but I am fascinated by them. I am fascinated by a lot of different animals. I love them to death, and so that impels me to be interested in and to find out more about them. And it's been a while. I've actually illustrated a book on reptiles a few years ago, and a lot of them were snakes. And so I had a chance to look at a lot of snakes in a bit more detail. And so that was fun. But I've just loved snakes for as long as I can remember, ever since I was a kid. Their color patterns are extremely gorgeous, and just so much diversity. There are so many. I think there are thousands of species of them, actually, several thousand. So there's a lot. It's a beautiful diversity. And if you look at them, just wow. Some of the things, some of them have other kinds of superpowers as well. Yeah.
Yeah. Do you know of any types of snakes that are blind?
Yeah, there are some actual snakes with really poorly developed eyes. And some of them live in areas where they wouldn't really need them. There are some burrowing snakes that don't really rely on vision a lot. Such diversity in snakes. And I'm not sure if any of them are actually truly eyeless. That's actually a really good question. Um, but I don't know if there are any actual eyeless snakes, like naturally eyeless. I mean, other than, say, a medical condition or a congenital problem. But there are some that with very poorly developed eyes. And these burrowing snakes, there's such diversity. There's groups of snakes that are mostly burrowing, that look more like worms than snakes in some ways. And some of those ones have very, very poorly developed eyes and almost effectively vestigial eyes, really. And they rely on senses of touch to find their prey, which are also burrowing prey.
Mm. Okay, I know we're really getting to the end here, so I'm just gonna ask these last two. Do you know the typical lifespan of a rattlesnake, and what drawing pad do you use?
Oh yeah, sure. Lifespan, I think they're known to grow up to about 25 years. Females start to produce babies around 7 to 9 years old. and they produce babies every about 3 years. They fast for 19 months while they're pregnant. They don't eat at all. So they have to take a long time before they can get big enough again to reproduce. So again, a reason why we have to be careful is they're very slow reproducing. So yeah, that's about their lifespan. 25-ish years, not much more than that. The drawing pad I use is actually I think it's a 21UX Cintiq. It looks like this. That's my drawing pad. And I use a stylus. It's my rainforest in the background. And so it's basically nice because I get to work on it, like not having to work here and look here. I get to work on what I'm seeing, basically. So these interactive LCD displays I find are very, very helpful. Although I also have a tablet, another Wacom tablet that I, is more portable. But they have so many different kinds nowadays, so many different brands as well. Anyway, I enjoy this. I love traditional artwork, like the acrylic on canvas. But for scientific illustration, I've often found digital techniques like this to be more effective because it's easier to change things as I go working with clients.
Well, a big thank you for everyone who joined today. It warms my heart to see so many people who care about these snakes or wanted to learn more, wanted to draw them. And a huge thank you to you, Julius. This is the last Learn to Draw of the year, but we will be having some new ones in the new year that we just planned. So get ready to see those. I hope to see you all there as well. And I hope everyone has a wonderful Wednesday. Thank you and goodbye.
Everybody, take care.